This video is about vertical angles. First, I'm going to show you how to recognize them and how to define them, and then we'll learn a really useful theorem that we'll be using for the whole year. In fact, my brother, who's about 7 years older than me, says it's the only theorem he remembers from geometry at all. What's interesting about this theorem is it's really the first one that is based upon another theorem. So the proof of the vertical angle theorem is based upon congruent supplements. So you can see that this material is already starting to build up, and that is becoming, very cumulative. And I hope that you're making flashcards or have secured some flashcard app to keep up with it, because it's really starting to get pretty late. So I hope you enjoy the video, and I hope you find it helpful. Thanks for watching. Suppose we were given this diagram, just two lines intersecting at a point A. You see that line BC crosses line XY and creates four angles, three of which I've numbered, 1, 2, and 3. Can you prove, using some of the theorems that we already know, that angle 1 is congruent to angle 3? Why don't you take a minute and figure out the proof and pause the video. Okay, hopefully you saw that you'd start out by saying that angle 1 and angle 2 are sup, and that can be assumed from the diagram. Secondly, you could say angle 3 and angle 2 are sup, and that's assumed from the diagram. And finally, you could come to your conclusion that angle 1 is congruent to angle 3 because if angles are sup to the same angle, then they are congruent. Well, we have another way, another theorem that we're going to teach you tonight called vertical angles. And it first starts with recognizing what vertical angles are. Vertical angles are made up of opposite rays. Opposite rays are two rays which share an endpoint and extend in opposite directions. Another way of thinking of it would be two halves of the same line. In our diagram here, AB is an opposite ray to AC. AX is an opposite ray to AY. So vertical angles are angles which are made up of a pair of opposite rays. So angle 1 and angle 3 would be vertical angles. Angle 2 and angle XAC would be vertical angles. It's not important whether the angles are actually situated vertically. So angle 1 and angle 3 don't need to be on top of each other for them to be considered vertical angles. But we don't need to go through all these steps anymore. You don't have to point out that angle 1 and 2 are sup, or that 3 and 2 are sup, or that angle 1 is congruent to angle 3. Now that we've proven this, you can skip these three steps and just go right to the theorem, which would say vertical angles are congruent. Pretty short, pretty easy, and strangely, it's one of the only theorems we'll meet all year that's not expressed in conditional form. Vertical angles are congruent. Okay, good luck on the exercises, and I hope this video helped.